Hey everybody, it's Eric Torenberg, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, welcome to another episode of Venture Stories by Village Global. I'm here today with two very special guests, Ivan Bogatyy of Metastable Capital and Amir Bandeali of 0x. Guys, welcome to the podcast.
Hey, Eric. Thank you for having us.
Yeah, thank you, Eric.
Let's start with some introductions. Ivan, can you get into what Metastable is exactly? And then Amir, we can get into what 0x is and then what decentralized exchanges are.
Sure. So Metastable is a cryptocurrency fund. It was originally founded on the thesis that cryptocurrencies would become the new money. And maybe the winning one would be Bitcoin, maybe not, but either way, we wanted to expose our LPs to all of that. It is one of the earliest crypto funds in the space. I believe the earliest that's not Bitcoin only. We've been in the space since 2014 and invested into the Ethereum on the pre-sale, Zcash early on, Monero, all the usual suspects.
And Ivan, how would you say that Metastable is different from Polychain or Pantera or some of the other crypto funds that emerged early on from approach?
I would say our focus is mainly on technical expertise. So we believe one of the very special aspects of blockchain is that it is a tech-heavy problem. There is no way to solve the issues right now without being deep in the weeds and understanding the consensus algorithms, all the subtleties of proof of work, proof of stake, and so forth. So I would say our fund is different in that every GP is technical, and then we do all of that diligence ourselves, and that's how we reason about the space.
Cool. Amir, you're the co-founder of 0x. Explain to the audience what 0x is, what a decentralized exchange is, and why people are so excited about it.
Sure. So 0x is a protocol for decentralized exchange. Yeah, but before I get into exactly what decentralized exchange is, I just want to make the distinction that 0x is not an exchange, it is a protocol. So there is another group of actors using the 0x protocol called relayers who sort of relay these canonical messages that represent orders to trade different assets, and those could be more analogous to an actual decentralized exchange. But the 0x protocol is a system of smart contracts on the Ethereum blockchain, along with this canonical messaging format that other parties interact with. So what is decentralized exchange? I assume most people are familiar with centralized exchanges and sort of how those work. So let's start there. On a centralized exchange, users will deposit their assets onto this exchange. Now the exchange is in complete control of those assets. And then when people trade with each other, the centralized exchange is, pretty much just adjusting numbers in some database, and then users are hopefully able to withdraw their assets at some point. There are a lot of issues with this model. I would say the main one being that you're giving full trust and control of your assets to the centralized exchange. In the crypto space, it's kind of been the wild, wild west in a lot of ways, and we have seen plenty of exchange hacks, hundreds of millions of dollars lost in these hacks, and decentralized exchanges have the potential to get rid of this completely. They're completely non-custodial. Users are always in charge of their own assets. So that's one of the main benefits of DEXes. But aside from that, there are other things that make them very valuable. So we're starting to see the emergence of sort of this decentralized finance stack. We have various protocols for like creating derivatives or taking out loans or stable coins, things like this that rely on some decentralized exchange infrastructure in order to be fully functional. All these different protocols and applications require decentralized exchange at some point along their pipeline. I could give some examples of that. down the line when we kind of get into the weeds of things. But the TLDR is that other decentralized applications are able to interact with decentralized exchanges, and this makes decentralized exchanges very valuable. And then finally, I think there are other applications where it just doesn't really make sense to use centralized exchanges. Normally when you hear the word exchange, you kind of think of finance, but the way we see it, in the long run, anything of value that can be tokenized will be tokenized. And this is just going to lead to a lot more efficiency in the long run. And this includes things outside of finance, like video game items, for example. And, if you're a video game developer and you're selling some items that can be used within your video game or within other video games, you're not necessarily in the business of exchange, and you don't want to set up a centralized exchange and hold on to people's assets and things like that. So it's just a lot more natural to use decentralized exchange for these sort of non-finance use cases, in my opinion.
So there are a bunch of players, 0x being a protocol, but others, right? EtherDelta, Banker, Uniswap, IDEX, Radar Relay. Can you sort of unpack the different players in the space and their approaches?
Yeah, so I would break down the different decentralized exchanges into a few categories. So first of all, you can break them down by if a user is trading directly from their own wallet versus the user depositing their assets into some smart contract. So with 0x, you're always trading directly from your own wallet. And then exchanges like IDEX and EtherDelta, you're depositing into their smart contract where the trade happens. So that's sort of the first distinction. The second is largely around how orders are matched or how trades are matched. So in 0x, we've seen two main models emerge, one of them being what we call the open order book model. So this is when a trader comes in and they see this order and they decide they want to fill it, and they just sign this Ethereum transaction to fill the order, submit to the blockchain, and then the trade is settled. There are advantages and disadvantages to this approach, which we'll also get to a little bit later, I'm sure. But then the other approach that we're really commonly seeing is what we call the matching model. So this is where you have someone who's sort of acting as a matching engine. It could be the relayer, this could be some other third party. And anytime they see multiple orders that are overlapping in price, they could just match them together, submit that to the blockchain. So in this case, the user is not actually really filling an order at their discretion. They're just passing orders to this matcher, and the matcher is the one who actually settles the trade.
To clarify, could you give a few examples? Like, if I understand correctly, the matching DEX would maybe be the IDEX, or I don't know, what else?
So matching DEXs would be like IDEX, Paradex, DDEX, the Ocean. Open order book DEXs would be like Radar Relay, EtherDelta, a handful of others. And then finally, I think there's this third class of DEXs like Bancor or Uniswap, which I would put into the automated market maker category, where these DEXs are holding some reserves of these tokens and algorithmically price those tokens, and people are just trading directly with the smart contract.
Makes sense. Before we get deeper into the weeds, I wanted to ask a bit about the foundation story of 0x. I know sort of EtherDelta was early on, and the reason I'm so excited to talk about DEXes is that it was one of the first kind of proven killer apps where one guy could sort of build this thing, which was, on the one hand, totally legal, but on the other hand, working and fulfilling the function of what essentially NASDAQ is doing in the non-blockchain world. And then sort of how did you guys go from there to deciding that you want to build 0x and sort of expand on the design space there?
Yeah, so Originally, when my co-founder Will and I met, we actually began working on something completely different. We were building a derivatives protocol for creating tokenized options on Ethereum. And we actually had most of the logic for that built out, smart contracts all worked and everything. But, at the time, this was like late 2016, I want to say. At the time, I think Ether Delta was kind of just starting. And for the most part, you just had a bunch of centralized exchanges. And even amongst the centralized exchanges, they didn't really list that many tokens. So we figured that, we could create as many options as we want, but they weren't going to be that useful unless there was a place to trade them. So we decided we were going to build a single for-profit decentralized exchange. But then after talking with a handful of other decentralized applications in this space, we realized that most of them had this exact same problem. They had some core product, and that core product needed decentralized exchange in order to function properly. So it became clear to us that just building a single DEX was not the answer, and that there needed to be this sort of core infrastructural layer for all these other decentralized applications to use.
Makes sense. And I'm totally with you that it seems like there's a lot of different use cases for DEXes. And if I whenever I want to trade something, I'd rather go to a DEX rather than risk my funds. But in practice, the 800-pound gorilla in the room seems to be that centralized exchanges seem to have vastly more liquidity than DEXes. I guess, can you expand on what you think that is, and sort of how would we go about increasing the, I guess I would say, lowering the discrepancy?
Yeah, so I would say the main reason is that using a decentralized exchange is kind of a new paradigm. The way trades are settled and matched and everything are very different than on a centralized exchange. And I think most professional market makers just aren't really used to that yet. They want to port over, their existing logic from a centralized exchange directly to a decentralized exchange. And it just doesn't really transfer over one-to-one. So they really need to rethink their strategies and their pricing models. They need to support a lot more infrastructure, I would say, or maybe not more infrastructure, but different infrastructure from what they're used to, right? They need to set up their Ethereum nodes, and they need to be watching the mempool and stuff like that in order to trade most effectively. They need to worry about gas pricing, potentially front running and stuff like that. And then of course, the throughput on Ethereum is much less than it would be on a centralized exchange.
So it sounds like there's, on the one hand, part of it is just plain friction, where people are simply not used to market making on DEXes, and probably not used to buying stuff on DEXes either. And that could be improved by simply people getting more comfortable with it over time and getting experience. And then there was this very interesting post on Masari that part of it is also fundamental, where essentially market makers really need the latency to be as low as possible. And essentially the order cancellation cost is this fundamental barrier to them market making profitably. So how would you sort of, on this sliding scale between people not having enough experience versus the fundamental scaling problems, which ones do you think would be solved first, and sort of which ones would be, I guess, solved by which means?
I think that they'll probably be solved somewhat in parallel, honestly. I think there could be a lot of shared infrastructure that's created to make the lives of market makers much easier. But alongside that, obviously a lot of different groups are researching various scaling solutions, and most of them do have applications for decentralized exchange. And I don't actually think that it's the cost of cancellations that's very problematic right now. I think it's more so the latency of cancellations. If you're going to cancel an order and that's going to take at least 15 seconds to get mined, there's a chance that order just gets filled in the meantime. And, the fact that your cancel isn't guaranteed isn't great. And this is also true of centralized exchanges as well. There's just much less latency on a centralized exchange, right? So just more latency will create more opportunities for front running and stuff like that.
Since you mentioned front running and that ties into liquidity as well, let's sort of first off give the listeners a bit of context. There's actually a bunch of different ways to make money on DEXes, which people sometimes don't distinguish between. I believe right now there's a lot of arbitrage going on, and the interesting part about DEXes is that this one can be done even atomically if there's a crossing pair of orders, be it within 0x or on two different exchanges, 0x to Ether Delta. People can implement smart contracts which would atomically buy one, sell the other, and make guaranteed profit. And then there's the front running, where essentially noticing an order in the mempool that's about to happen. It gives traders a certain amount of information that they could make money on. So sort of instead of filling the orders, at least to the benefit of the public, they essentially are a pure value net negative, profiting at the expense of everybody else. So as far as that ties into order cancellations, the ultimate competition is between market makers trying to cancel their order versus the trader trying to buy it up while it's profitable. So have you guys seen these kinds of wars between market makers and arbitrageurs?
So we haven't seen a ton of it on 0x, actually. I know Phil Dian has done some studies on this on Ether Delta, I believe. I'm not sure if he's looked at other DEXes, and has seen a decent amount of front running. I think the website is frontrun.me, and you could kind of see these like auctions for every single trade where people are just kind of front running each other until one transaction finally gets mined, and then everyone else just ends up wasting gas. These are two ways to make money. I think arbitrage is a good feature, or atomic arbitrage is definitely a good feature, but that also creates opportunity for front running, obviously. But I think what I'd like to see more of is just people tuning their pricing models to be able to make money despite front running, basically, right? Like I think right now, with the current limitations, spreads will probably be a little bit wider. But I also think that the user base is largely price agnostic, and there are certainly ways for market makers to make money otherwise.
So that's actually what surprises me as well. You mentioned Phil Dian's research, and it looks like there's a lot of technical sophistication that goes into front running, where they not only do they bid on pricing, they also have networks of nodes where essentially they compete on latency and try to sort of give their order to the miner as fast as possible. So it sounds like there's a lot of technical expertise in DEX trading, but for whatever reason, none of that goes into market making. And like you said, if people were comfortable widening the spread a little bit, it sounds like they could be creating a lot of value by providing liquidity as opposed to taking it. So what do you think are the barriers to that skill going towards market making as opposed to arbitrage or front running?
Yeah, that's an interesting point. I would say that arbitraging and front running, front running is almost a form of arbitrage, and both of these things are not very capital intensive, right? Like there's potential to do them with like basically no capital up front, right? If you use like, some sort of flash lending protocol, you could just borrow some assets,
right.
Or arbitrage and make money. Whereas if you're market making, you need to hold an inventory of whatever assets you're market making and stuff like that. And, there's definitely some larger cost of capital there. So, in traditional markets, most of the market makers are, you're probably not holding that much inventory. And if you're selling something, you're just opening up a short position, which is much harder to do on a decentralized exchange right now.
Oh, that's very interesting. So the argument about inventory definitely makes sense because some of the Ether Delta frontrunners, they actually make thousands and thousands of Ethereum, and it looks like they're sort of not cash constrained. Sometimes they would even waste as much as tens of thousands of dollars on sort of arbitraging a single order. But it definitely seems like holding on an inventory of less well-known tokens would be a bigger risk for a market maker. Do you think short selling positions, so I don't know, once a DYDX lets people short stuff, do you think that would make market makers more comfortable with larger inventories?
Yeah, I do. I think just the ability to borrow these assets in a more frictionless way, I think will really help with liquidity overall. Also, a lot of these market makers might not be capital constrained, but that doesn't mean that they can't deploy their capital more profitably elsewhere. So, the other thing with market making is there's a bit of a chicken and egg problem where liquidity is going to beget more liquidity, and it'll draw in users, and then that presents more opportunity for the market makers, and then it's kind of a virtuous cycle.
Okay, that definitely makes sense. One more question on market makers to close the loop. Do you guys keep in touch with any of them? Do you sort of help them? I know MakerDAO writes keeper bots for people to essentially run without putting in that much engineering expertise. Do you plan doing anything similar?
Yeah, definitely. So right now, most of the tools we have are a bit lower level, but we are going to be rolling out more tools specifically for market makers. We're going to be rolling out tools in other languages like Python that most market makers are more comfortable with. We do talk with a lot of market makers, mostly to get general feedback about things, like our APIs. We use something called the standard relayer API, which all relayers should implement, and then all these relayers can basically be traded on with a single API, which I think helps with liquidity. But yeah, right now it's mostly about getting feedback, researching where the hiccups are, and then addressing those issues by releasing tools or features.
Makes sense. And I'm not sure how secretive these teams are, but can you give a bit of color on sort of, are they institutional? Are they sort of hackers out of China and Russia? Sort of anything in between?
I don't know of many institutions, I guess. I've seen a few companies or a handful of companies that market make on decentralized exchanges specifically, and like that's their whole business model. And then there are also a lot of individuals or small groups of people that are kind of doing it on the side, and maybe they recognize opportunity, they have some experience trading on centralized exchanges and stuff like that. But I think there are still some barriers to entry for the institutions. One being that they need both sides of a trade to be guaranteed to be KYC'd, just for AML reasons. And then a lot of the other ones, like crypto funds can't hold custody of their own assets in a lot of cases. So, if you just have your assets with some custody provider, it's difficult to trade from that wallet, although this is something that we're also going to be addressing soon.
To zero in on 0x, I believe people who tried trading on Ether Delta or are familiar with the sort of basic DEX design of on-chain order books, they should probably have a pretty good idea of how 0x V1 works. With that in mind, can you give a bit of an overview of what is 0x V2, what were the main product drivers behind the update, and sort of what were the main changes?
Yeah, so I would say there are three sort of classes of major changes in V2. So probably the most major change is the ability to trade arbitrary asset types. So the high-level architecture of V2 is still pretty similar to V1. You kind of have this exchange smart contract, and then you have these proxy contracts, which users approve to transfer their assets, or it'll do the calculations required for verifying a trade, and then it'll sort of forward that to the proxy contract, which will actually transfer funds from each of the traders' accounts. So version 2 uses this architecture, but instead of having just a single proxy that is only able to transfer ERC20 tokens, there are different proxies for different token standards. And these proxies can decode data that is specific to these token standards, and that data can just be stored in a byte array of arbitrary length. So in this way, it's very easy to add support for any new standards. So I think this is really important because it opens up doors for decentralized exchange to non-financial applications. First of all, non-fungible tokens have been very popular. You know, we originally just saw a lot of non-fungible token projects releasing collectibles and very simple games and stuff like that. And now we're starting to see more complex games in the pipeline. I think another important piece of this is that it allows developers to, like, let's say you're a video game developer and you want to release some video game item as a token and you're not really sure which token standard to use. There are a few different token standards with different trade-offs, and maybe you want to use the brand new shiny one, but you have no guarantee that this standard is going to be adopted in the long run. And you don't necessarily want to bet your entire business on this, right? Like, what if, you know, I decide to release video game items as an ERC 1155 token, but it just ends up not being used? Does that mean my business is dead? Well, if you're able to trade all of these different asset types with each other, you're not really actually taking that much risk, right? Because you still have this canonical 0x order format, and that could be traded with any other asset type that currently exists or will exist in the future. And I think this is just going to encourage a lot of innovation in the space of decentralized applications. I would say the next main feature is the ability to write what we call extension contracts. We have the core logic of the 0x exchange smart contract, which is just used for settling trades. But let's say you wanted to guarantee that all of the traders on your relayer have been KYC'd, okay? You're an institution and you're not going to trade on a relayer otherwise. Now you can very easily do that with basically a few lines of code by writing an extension contract. And this extension contract would just verify that, you know, both parties of a trade have been KYC'd. This is, you know, assuming there's some on-chain KYC whitelist. If it passed that check, it would go ahead and execute the trade. And this contract is like extremely simple to write. It doesn't require custody of any funds or anything, and has all the same guarantees as the underlying protocol smart contracts. So there are a lot of things you could do with these extension contracts. I would say KYC whitelist is like the most basic example, but, you know, let's say you wanted to enforce some sort of a max gas price on trades that are executed on your relayer. You could do that with this. Let's say you wanted
that would actually be very interesting, right? Because so you mentioned 0x doesn't have as many gas wars as Ether Delta, but still I think that would be a benefit to market makers, because if they, for example, if people can pay up to 101 GUI for canceling an order, but up to 100 for bidding on an order, that would practically solve the problem of front runners making money at the expense of market makers, which is actually what Bancor did, and it seems to have worked out for them.
Yeah, that would be very easy to do.
So you mentioned two updates, right? The different, the arbitrary asset type listing, and then the extension contracts. What was the third?
Third is we added a handful of different signature types into the protocol. So when you create a 0x order, You hash all the parameters together, you sign that with your private key, and then the smart contracts are able to verify that the signature is authentic and then settle the trade. In version 1, it just supported standard ECDSA signatures. And then in version 2, there's now support for standard ECDSA signatures, as well as EIP 7 or signatures using EIP 712 hashes. So EIP 712 it's a standard for signing typed data. So if you've ever used a decentralized exchange using MetaMask or something, and you're creating an order, MetaMask will flash this big red warning, beware, make sure you trust what you're signing, and it'll just show you like this hash, right? And that's what you're signing, and you kind of just need to trust that you're signing the order that you actually intended to sign. So with EIP 712, you'll be able to see all of the exact parameters of that order, and you could very easily verify that it's the correct thing you wanted to sign. And then in addition to that, you're now able to sign orders via smart contracts. So this is sort of where that custodial piece comes into play. You could actually trade from a multi-sig, for example. You could create multi-sig orders. So let's say you're a crypto fund and you have your assets with some custody provider. Maybe those assets are stored in a multi-sig, and you can actually make a trade on a DEX with a signature from both yourself and from the custody provider.
Makes sense. So when I was reading the V2 release doc, the new signature types was what seemed the most interesting one to me, and sort of what immediately popped into my mind is that now you can have all kinds of trade coordination engines, potentially even private order books or any other different strategies for matching orders. So I wanted to ask you a bit more on sort of, would that imply different relayer setups? Would you experiment with sort of some relayers using the old ECDSA signature versus the new ones, trying out maybe more like a matching IDEX style order books, and sort of how much complexity would that entail, and sort of how are you thinking about that?
Yeah, so I think a lot of these use cases do require sort of specific relayer setups, and that's probably why we haven't really seen that many extensions being used in production yet. But I think ultimately these just allow for new classes of relayers to pop up and experiment with different strategies. And I think in the long run, you probably end up with a handful of these different extensions and types of relayers, and different relayers within each category are probably using the same set of extension smart contracts. But yeah, like you said, it's very flexible. You could create like a commit and reveal relayer or something like that, which would prevent front running. You could also create what we call a trade execution coordinator. So what this is it's sort of a mix between the open order book and the matching strategy. So basically you would ask a relayer, can I fill this order? Or ask the coordinator, can I fill this order? The coordinator would sign off on it and give you their signature. And then you could pass this signature into a smart contract and settle the trade. So you're still executing the trade sort of at your discretion. You can still use that as part of a long chain of smart contract calls, but you're trusting that the coordinator is, preventing other people from taking the same order, which then prevents front running. So you kind of get the benefits of both models in this scenario. In its simplest form, there's just a single coordinator who's deciding which orders can get filled at which times. But I think in the long run, this ends up looking like an actual network of coordinators who are coming to consensus about which orders can be filled.
How are you thinking about so it sounds like the trade coordination would be kind of a boost to liquidity because now the orders would go through faster, and as long as you trust the coordinator, you don't have to wait for block confirmation. So that's one solution. Another one that people are thinking about would be either plasma side chains or state channels. How are you thinking about sort of state channel DEX designs? Do you think they're viable, or do you think that's kind of further down the line, or maybe not even efficient at all?
I think we're more interested in plasma style DEXes or sort of other sidechain models. With state channels, I don't think they work that well for a large amount of participants. Plasma seems much better for that use case. We're really interested in the plasma approaches that use Starks and Snarks specifically. I think those scale really well, and they're probably honestly not as far out as people think they are. Some of the other plasma models I think are a bit harder to generalize for decentralized exchanges. But yeah, I think generally plasma is the approach that we're looking at most. I think there are also just like simpler forms of plasma that could be valuable here. So for example, let's say you have this trade execution coordinator, and I ping the coordinator and say I want to cancel this order. So normally I would still need to wait for that cancel to be mined on the main chain, but you could potentially have these coordinators just commit to like a plasma side chain, say, hey, look, this order is canceled. And then if they were to fill that order on the main chain, someone could submit a proof that it was canceled on the plasma chain, and the coordinator could get slashed or something like that. So yeah, I think there are a lot of different applications there.
Since we don't have that much time left, I wanted to sort of ask you a bunch more random questions about different things. What do you think about the centralized exchanges running their DEX version? So Efinex, Binance DEX, have you paid much attention to that?
Yeah, a little bit. I mean, I definitely like what Efinex is doing. I think that's a cool approach, and I like that they're still sticking to Ethereum, and like that comes with being able to trade all the different assets on Ethereum. I think there are less details around what some of the other centralized exchanges are doing.
So can you actually give a bit more detail on what Efinex is doing?
Yeah, so as far as I know, they basically have this DEX order book that is taking liquidity from their centralized exchange. I'm actually not 100% sure if they're still doing this or doing this yet. But I think the idea is that you would be able to fill an order on the decentralized exchange. They would just match that liquidity on their centralized exchange, and that way you could sort of trustlessly interact with their order book.
Oh, that's very interesting. And how would you confirm those orders? Is it just trade? So I guess one option would be to have a trade coordinator that simply signs that a certain transaction went through, and then it's kind of centralized, except you can verify if they're screwing you, or is it more complicated than that?
So I think it's basically using the matching model. So since they're kind of matching orders at their own discretion, they can also fill orders on Bitfinex at their discretion. Again, I'm not actually 100% sure if this is what they're doing, but I know this was in their plans a while ago. I mean, I think it's a really interesting model. Just in general, like, I think we need to see more market makers mirroring the liquidity from centralized exchanges. I think that's like a pretty easy and simple business model. Just mirror that liquidity and charge a bit of a spread. And yeah, could potentially solve a lot of the market making problems.
One model we didn't talk about as much was the one you dubbed automatic market making. So that's essentially Bancor and Uniswap. On the one hand, this seems very interesting and definitely an innovation that's specific to the blockchain world. On the other hand, Amin Gunser had this very interesting post about Bancor, essentially saying that it would be implausible to think that sort of if the rest of the world cannot figure out a profitable market making strategy, then a sort of a formulaic approach like the one Banker has could be profitable. I'm still sort of undecided on that. I guess where do you stand on whether this automated market making could work out versus sort of in the long run it would be exploited away by sophisticated participants?
I definitely don't think that it's the best long-term solution. I think where it shines is sort of the ability to have guaranteed liquidity regardless of price. But I think in general, they suffer from all the same problems as other DEXes, such as front running, and are generally less liquid. And there's less opportunity for other participants to come in and sort of compete with each other and try to make money by providing liquidity. Yeah, but I think if you absolutely need some token and absolutely don't care about the price, I think that's where it kind of makes sense to use automated market makers.
Interesting. That makes sense. I may be mistaken, but I think you guys have some partnership with DYDX to also list derivative tokens. Can you give some color on sort of how would those be listed? How would you differentiate between sort of the different strains of, let's say, the short Ethereum token, and how could people get those?
Yeah, so first of all, since 0x is not an exchange, we don't list any tokens or anything like that. It's just any arbitrary tokens are able to be traded over the protocol, and it's kind of on the relayers to determine which tokens to list on their end. DYDX specifically uses the 0x smart contracts, I believe, when you're initiating positions, and I think also maybe when collateral is liquidated. I think you would trade both their short and margin tokens on Radar Relay right now. I think generally we're really interested in the project. Like I said, we kind of started with derivatives, so all these different derivative protocols are pretty interesting to us, and I think really aligns with our long-term vision of kind of everything in the world becoming tokenized. And I also think they're a great example of protocols that require decentralized exchange to function. Just in general, any lending protocols, if someone gets margin called and their collateral needs to be liquidated, that needs to happen on a decentralized exchange.
One question I'll have is, what do you think are the biggest misconceptions people have about 0x or maybe even the category broadly?
I think it's very common for people to think that 0x is an exchange and is listing tokens and stuff like that. We'll get emails how do I list my token? So that's definitely one. Yeah, the other is sort of that DEXes can only be used for financial applications. I really think in the long run, the types of assets that are going to be tokenized are probably mostly non-financial assets. And I think that's where DEX is really going to shine. And people just haven't seen that yet because, there aren't that many non-financial blockchain applications in production yet.
I mean, you talked a bit about DEXes outside of finance. Which applications are you most excited about existing? Or if you were to sort of have a request for startups or request for innovation for talented people out there who are curious about this and want to build, where would you want them to focus on?
Short term, I'm really excited about video games. The entire video game does not need to be on-chain and should not be on-chain, but I think just being able to own assets within video games and have those be interoperable potentially with other video games and stuff like that. I think it's just one of those cases where there's just clearly extra value to the end user. And I think that could attract a lot of new users into the blockchain space.
Awesome. Thank you both for coming on the episode. Any last minute plugs for either of you terms of what people should stay tuned for as regards to Metastable or 0x? Ivan, perhaps you start, or where people can follow you online.
So I'm on Twitter and Medium. Overall, Metastable isn't very vocal. We sort of try to stick to fundamentals. One thing I think would be helpful is I'll send over a bunch of links relevant to the subjects that we discussed. So that would be stuff like Amir Bandali's research on front running, our post with Hasib as far as front running Bancor, 0x V2 product release. I think you guys had an excellent blog post. So I'll send that over, so that should be interesting grounds for people to follow up. And definitely check out frontrun.me to see people fighting with each other in real time. I would say that this is arguably the most sophisticated use of the blockchain right now, which I think is pretty exciting.
Totally.
Cool.
Amir, how about you?
I would say expect to probably see more specialized relayers in the future. We're working with different extension contracts and stuff. There are definitely a couple extension contracts in the pipeline. And then, excited to start seeing more non-fungible token and video game item marketplaces and stuff like that coming online. But yeah, I think so. Right now, you look at frontrun.me and all these people are bidding on a single transaction, and one ends up winning, and the rest of these people just end up wasting gas, and the miner kind of ends up profiting the most. And I think this is kind of a fundamental problem with the fee model of Ethereum. Not to say that there are better models generally, although there probably are, but I just think it doesn't work well for front running. Basically, it encourages front running or makes it a larger problem because people end up losing more money. Whereas, like, let's say you had a model where like everyone's still trying to bid on the same order, but only the winner of that auction ends up paying the fee and the rest of the transactions aren't even mined or something like that, it becomes much less of a problem because there's just a lot less wasted fees going to the miner.
So interestingly, as you mentioned this, people are already kind of doing that in their sort of hacky little ways. And so, for example, if you do a typical Ether Delta order and that one fails, you pay a ton of gas because it's this huge reverted transaction. So what arbitrageurs typically do is they do a little proxy smart contract that first checks if the order is still available. And then if it's not, then they exit and they pay a much smaller amount of gas. And so they kind of save money in this bidding war where sort of if you win, you pay for the full transaction. If you lose, you pay for just the conditional check. But obviously, like you said, sort of that's a solution that's native to the chain would be preferable to people sort of hacking different things and kind of replicating that work to minimize their losses.
Yeah, definitely.
Cool. Well, guys, thank you both so much for coming on the podcast. It's been a great episode.
Yeah, thanks. Thank you both, Erik and Ivan. Really glad to be here.
Thank you. Yeah, enjoyed talking to you a lot.
If you're an early stage entrepreneur, we'd love to hear from you. Please hit us up at villageglobal.vc/network catalyst.